Okay, so here's the homework for targets 10 and 11. It is listing all possible rational zeros and using synthetic substitution, synthetic division, and all that good stuff. So target 10 is listing all possible rational zeros to start and then testing them. So looking at number 1, we're going to first write all the factors of the very last term, which in this case is 12. So let's see, 1 goes into 12, 2, 3, 4, 6, and then 12 goes into 12. And then all factors of the first term just being 1. If there's nothing there, always just assume that it's 1. So I'm just going to say 1. And then all possible rational zeros, that's when I actually have to take all the last factors and put them all over the first. So in this case, we only have one factor of the first term. It's just 1. And so basically, I'm just going to create fractions like 1 over 1, 2 over 1, 3 over 1, 4 over 1, and just keep going. And 1 is my only denominator that I have, so I'm just going to go ahead and make those all whole numbers. So I have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and then plus or minus 12 over 1. So those are all the possibilities that I could possibly have for the rational roots. The actual rational roots is going to come from me testing these with synthetic division, trying to get these down to a quadratic, and then factoring from there if I can. I'm going to go ahead and start with something easy. I'm going to start with just like 1. I'm just going to start with 1. Let's see if that works. So I'm doing, I'm going to do synthetic division with the number 1 into that polynomial. So I'm going to make my little box, have 1, and then the coefficients that I write inside my box, if you notice, I actually have to add a plus 0x squared. So it's going to go 1, 0, negative 13, negative 12. All right, bringing down my 1 first. 1 times 1 is 1. I add that to 0 to get 1. 1 times 1 is 1. Add that to negative 13, I get negative 12. 1 times negative 12 is actually negative 12, and when I add those together, I get negative 24. That is not 0. So 1 is not a rational root. Doesn't work. Let's try something else. I'm just going to keep going in the simple way. I'm going to try negative 1. 1, 0, negative 13, negative 12. 1 times negative 1 is negative 1. When I add those together, I get negative 1. Negative 1 times negative 1 is positive 1. When I add that to negative 13, I get negative 12. Negative 1 times negative 12 is positive 12, and there we go. That's going to get me 0. So that works, which means that negative 1 is a rational root. All right, what I'm left with here, if you notice, 1, negative 1, and negative 12, those are the coefficients of my new quadratic. So here, my 0, that was my remainder. 12 is my constant, negative 1 is my x term, and then 1 is my x squared term. So those are all my coefficients in front of my quadratic. So I am left with x squared minus x minus 12. So I'm going to see if I can factor that, because factoring at this point would be a little bit easier than doing the synthetic division again. If I can factor, I know how to factor pretty quickly. The a value here is 1, so I'm just going to see, are there any factors of 12 that are going to add up to be negative 1? So multiply to get negative 12, add to get negative 1. And actually, yeah, it's negative 4 and positive 3. So I can just skip to this step here, x minus 4, x plus, oops, not 1, plus 3. All right, so my actual rational roots are going to come from here, here, and here. Okay, so since I already have x equals -1, all I have to do at this point is solve for both of these factors. So x minus 4, when I set that equal to 0, I get +4. And then when I set x plus 3 equal to 0, I get -3. That's my answer. X equals -1, x equals +4, and x equals -3. So what I did was I did synthetic division until I got a quadratic. Then I factored my quadratic like I knew how. All right, let's try another one. Give myself a little room here. Okay. So factors of my last term, which in this case is 8. So I have 1, 2, 4, and 8. And then factors of my first term, which in this case is 3. I have 1 and 3. And then all possible rational roots. I'm going to create all possibilities, fractions and whole numbers, everything that I possibly can, using this fraction here, all the blue over all the red. So I have plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. Now I'm going to create fractions, putting all those blue over the red 3. So I have plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, and plus or minus 8/3. And none of those simplify to like repeat with any of the ones that I had already written, so I'm just going to write all those. All right, let's try synthetic division now with any one of those. I'm just going to start the easy way again. I'm going to start with 1. Let's see, writing out my coefficients. I'm not missing any terms, so I'm just going to go 3, 7, -22, -8. Bringing down my 3. 1 times 3 is 3. 7 plus 3 is 10. 1 plus 10 is 10. 10 plus -22 is -12. 1 times -12 is -12, and when I add those two together, I get -20. All right, well, that's not going to work. So I know for a fact that 1 is not a rational root. Let's try another one. Try another easy one. We'll try -1. 3, 7, -22, -8. -1 times 3 is -3. Add that to 7, I get 4. -1 times 4 is -4. Adding that to -22, I get -26. Times -1 is +26. When I add those together, I definitely don't get 0. I actually get 18. So that's not going to work again. Let's move on to something else. Let's try 2. 3, 7, -22, -8. Bringing down my 3. 2 times 3 is 6. 6 plus 7 is 13. 2 times 13 is 26. Plus 22 is 4. Oh, 2 times 4 is 8. That is actually going to work. I get 0. All right, which means that 2 is a rational root. I can write that up here already, actually. I know that x equals 2 is one of my answers. So what I'm left with, 3, 13, and 4. 0 was my remainder. In this case, it was 0, so I don't have a remainder. 4 is my constant coefficient. 13 is my x, and then 3 is my x squared coefficient. So what I'm left with up here is 3x squared plus 13x plus 4 equals 0. Now, I'm going to try to factor this using the AC method. If you would like to go ahead and use the quadratic formula for this, you totally can. I think that factoring is just a little bit easier, and we could always use more practice with it, so why not? So AC method, 3 times 4. That gives me +12. So I'm trying to think of two factors that multiply to get 12, but add to get 13. In this case, it's just 12 and 1. That actually is going to work. So I'm going to split up 13x into 12x plus 1x, leaving everything else the same. Now I can go ahead and factor by grouping. I'm going to take out a 3x here, and I'll be left with x plus 4. And I'll take out just a 1 here because it's already x plus 4. So now I have 3x plus 1 times x plus 4, and I can solve those to get my other roots. 3x plus 1, when I set that equal to 0, I get negative 1/3. And then when I set x plus 4 equal to 0, I get x equals negative 4. So x equals negative 1/3 and x equals negative 4. Those are my other roots. All right. Those were a little long. That's okay. Good practice. Let's move down to target 11. I can rewrite a polynomial in factored form using synthetic division and other factoring methods and find all zeros. All right, so it wants us to use what they give us, the polynomial and the factor, and go ahead and do synthetic division. So let's see. 1. The reason I'm doing that is because I set x minus 1 equal to 0, and then I actually get x equals 1 when I solve. So I do 1, negative 3, 2. Bring my arrow down, bring 1 down. 1 times 1 is 1. When I add those together, I get negative 2. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. All right, so my factored form, what I'm left with now, if you can see, 0 was my remainder, negative 2 is my constant term, and 1 is my x term. So I can write my answer. Normally we're left with a quadratic from this lesson, but x minus 2 is what I'm left with. And I already had x minus 1 from what they gave me in the problem. So the factored form is just this, x minus 2, x minus 1. And then the zeros are just going to come from me solving those. When I set those equal to 0, I get positive 2 and positive 1. All right, let's do another one. Same thing, I'm going to set x plus 1 equal to 0, and I get negative 1. So negative 1, and then I have 1, oops, not 3. I was looking at the degree. 1, 7, 11, 5. Bring down my 1. Negative 1 times 1 is negative 1. I add those together, I get 6. Negative 1 times 6 is negative 6. Add those together, I get 5. Negative 1 times 5 is negative 5. I add those together, I do get 0, so it works. 0 represents my remainder, 5 represents my constant, 6 represents my x, and then 1 represents my x squared. So I'm actually left with a quadratic here. X squared plus 6x plus 5. So if I can factor that, which I actually can, factors of 5 that add up to be 6 are 5 and 1. Since my a value is 1, I just get x plus 5, x plus 1. So my factored form is going to come from combining what they gave me and then what I just got as my factored form of the quadratic that I was left with. So x plus 5, x plus 1, x plus 1. And my zeros, I get x equals negative 5 when I set x plus 5 equal to 0. And then I also get x equals negative 1, but I'm going to say multiplicity of 2 because it happened not once, but twice. X plus 1 was a factor twice, so when I set that equal to 0, I get negative 1, but I actually get negative 1 with the multiplicity of 2, meaning I have it twice. Alright, I think that's it for that page. Let's go to the back. Same thing here. I'll bring this cubic down to a quadratic first. X minus 1 equals 0. When I solve that, I get x equals positive 1. So when I put 1 up here, 1, 7, negative 1, negative 7. I wasn't missing any terms. 3, 2, 1, 0, so I don't have to add any zeros. 1 times 1 is 1, 7 plus 1 is 8, 1 times 8 is 8, plus negative 1 is 7, times 1 is 7. When I add those, I get 0, so I'm left with this quadratic here. 0 was my remainder, 7 was my constant, 8 was my x, and 1 was my x squared. So I have x squared plus 8x plus 7 equals 0. And then my a value is 1 here, so factors of 7 that add up to be 8, 7 and 1, x plus 7, x plus 1. And then when I set those both equal to 0, I'm going to get negative 7 and negative 1. So my factored form is going to come from what they gave me and also what I factored. So I have x plus 7, x plus 1, x minus 1. My zeros are x equals negative 7, x equals negative 1, and x equals 1. Looking at the next one, x plus 1 equals 0. When I solve, I get x equals negative 1. So negative 1 is going to go here. I'm not missing any terms, 3, 2, 1, 0 with my variables and my exponents. So 1, negative 9, negative 21, and negative 11. That's what goes in my synthetic division box. And we'll start with this. So bringing down my 1 times negative 1 is negative 1. Add those together, I get negative 10. Times negative 1, I get positive 10. Adding those together, I get negative 11. Times 1 is positive 11. When I add that to negative 11, I get 0. Alright, so 0 is my remainder. Negative 11 is my constant. Negative 10 is my x, and then I have 1 as my x squared coefficient. I'm left with x squared minus 10x minus 11 equals 0. And then I can factor that the quick way by doing factors of negative 11 that add up to be 10, and it's just negative 11 and positive 1. So x minus 11, x plus 1. So my factored form is just going to come from what they gave me combined with what I just factored. X minus 11, x plus 1, x plus 1. And if you see this again, just like we saw on the front page, I have not once but twice is x plus 1. So my zeros are going to be x equals 11, x equals negative 1 with a multiplicity of 2. I just have it twice because I had that factor twice. Factor each expression completely. Remember to look for a common factor first, then use the AC method. So this is just some factoring practice that we can do. At number 12, I can factor out a GCF of 6. And I'm left with x squared minus 5x plus 6. We're not solving here, we're just factoring. So let's see. Factors of 6, that'll add up to be negative 5. 6 and 1 wouldn't work because I have to have a positive 6, but negative 3 and negative 2 would work. So keeping my 6 out front, I can just change this to x minus 3, x plus 2. Alright, number 13. My a value is 1 already, so I don't have any GCFs. So I'm looking for factors of 12. I'm sorry, factors of negative 12. It'll add up to be negative 4. In this case, it is 6 and 2, and I have a negative 6 and a positive 2. So p minus 6, p plus 2. Easy enough. For this one, I don't have any GCFs, so I'm going to have to use the AC method the long way. 15 times negative 2 is negative 30, and I'm trying to see what would add up to be negative 1, which is my B term. So let's see, factors of negative 30. 5 and 6 has a difference of 1, so negative 6 and positive 5, when I add those together, I will get negative 1. So I'll split up my b term. 15k squared minus 6k plus 5k, oops, minus 2. Oops, not even equals 0. We're not solving, we're just factoring. All right, everything stayed the same. I just broke up my b term into negative 6 plus 5. Now I'm going to go ahead and factor by grouping. I'll take a 3k out of the first. I'm left with 5k minus 2, and then I'll just take a 1 out of the second pair because it's already 5k minus 2. Now I'm pretty much done. I can combine this to 3k plus 1 and 5k minus 2. Whoops. All right. And then finally, number 15, I do have a GCF here. I can take out a 3. So when I divide all those by 3, I get 7x squared plus 30x plus 8. And then now I'm looking for, if I do my AC method, factors of 56, that'll add up to be, add up to be 30. Let's see, 56, I'm not even sure the factors of 56. 56, whoops, not 56, it's 2. 28 and 2. 14 and 4. 7 and 8. 28 and 2 would make 30, and it all has to be positive, so 28 and 2. So I'm just going to break up my middle term, my b term, which is 30x, into 28x plus 2x. I'm going to change to a bracket also, because I'm going to have a lot of double parentheses here. 7x squared plus 28x plus 2x plus 8. Not even equals 0. I don't know why I keep doing that. I keep wanting to solve. We're just factoring. So now I can do factor by grouping. I can factor a 7x out of the front two, and I'm left with x plus 4. And I can factor a 2 out of the second two, and I'm left with x plus 4. Now x plus 4 and x plus 4 are the same, so I can just combine this all to be 7x plus 2, x plus 4. All right, and that is it. If you have any questions about the homework, don't hesitate to ask any of the Algebra 2 teachers.